So welcome to the Cisco U Theater. So you've probably heard a lot about Cisco U. Cisco U is Learning and Certification's new digital learning platform. Everything that you see in the Cisco U Theater, our idea was to bring Cisco U content to life. So you can start on the digital platform, you can come to Cisco Live, experience all sorts of in-person content, and go back home and continue your learning journey, all shaped to you. So there's a lot more to learn about Cisco U. You can get a demo back there from our pal Kareem or Ashley, who is actually the product owner of Cisco U. I changed your title, by the way. I made you product owner.
Changed my title?
Yeah, instead of product manager, made you owner. Anyway,
Oh.
So for a special treat for all of you, so Cisco U is not generally available at this moment in time. However, if you go to this QR code and you give us just a little bit of information, you guys will all have free access to everything on the Cisco U platform until the end of March. Gives you 6-7 weeks to prep for your CCNA. There's going to be 9 learning paths around our 9 most popular certifications. There are learning paths around becoming a security analyst, around cloud fundamentals, all sorts of content for you guys to learn. So definitely access the QR code. You'll get access on Monday. You'll get an email from me and my team, which will be super exciting. You'll remember me in this moment. But right now, I'm going to pass it off. Oh, and Ashley's going to do a raffle. We'll take our Vanna moment there. You all should have gotten a little yellow piece of paper. Ashley will be drawing the winner at the end of his presentation. But after all of that, make sure this is going away. It's not really going away. It's also in front of you. So, make sure to download the QR code. I will pass it off to Ashley, who is a product manager, but used to be a developer evangelist. So he knows this topic really well. So without further ado, learn about Git.
Okay, can you hear me? Doesn't sound like it. No? Yes, no? Yes? Oh, apparently I don't have my mic shooting back at me. So is that volume okay? Okay. Julio says louder. Okay. If I do that, I'm gonna do my problem. So we don't want to do that. Okay, cool. All right, so we're gonna cover Learn Git in 15 minutes, although we have 30 minutes, so we'll talk a little longer than 15. Fantastic. So my name is Ashley Roach, as Lacey said, and yes, former developer evangelist, maybe retired, although I'm coming out of retirement just for this session. So, maybe get excited about that. Are you pumped up about that? Okay, all right, okay. All right, so let's start with what is version control. Who here uses version control? Who uses Git for version control? Okay, why are you in this session? Maybe I'm gonna pick on you guys perhaps. Okay, so version control is really a system that manages these changes of files within your computer, and it's really to help you so you don't shoot yourself in the foot. And so a lot of systems now, more and more systems, we use Google Docs, right? Does a lot of people use Google Docs? Google Docs has version history. It's just automatic. It goes crazy though. You have oh, I typoed this thing and it saves the typo. You'll see with Git, you get a little more control over what gets saved when. And with Git, it also isn't fully based on the whole file. It can look at changes just within the file and so on. So you could think of this if you're completely, are there any complete novices with Git or version control? Okay, all right, so 20%. All right, what are the rest of you people here for then? No, we're gonna cover it, it's good. Okay, so version control is similar to snapshots in VMs. So you take a snapshot after you've done your initial build of it because oh, I might make a mistake, I need to go back in time. It's similar to like incremental file backups. Also, it's all about trying to put these checkpoints in your work so that you don't lose that valuable work. So when you do make a mistake, though, you can go back in a safe way for the actual content. So what is Git? So Git is an open source distributed version control system. It has these other attributes. So it's really, when it was designed originally, it was designed around building the Linux kernel. So Linus Torvalds, who invented Git, was tired with centralized version control, and so he's a smart guy. So he was like, "I'll design my own version control system," and Git was what he came out with. So some of these other attributes are interesting, but I'm not really going to go too deep into them. It's a quick session. But trees are one of the fundamental concepts underneath. You really ultimately don't need to know that much about trees because you very rarely even see that commentary in the command line and everything. But trees are where your changes go, and then you can manage those trees. So this is like some of the branching and tree concepts within Git, just visually. But that's like their icon. One thing that people tend to do is they'll equate Git with GitHub, or even GitLab. So has everyone heard of GitHub? GitLab? Okay. So Git is the open source protocol. It's the open source technology that enables this mechanism of version control. GitHub, GitLab, or even Atlassian has a product around version control, Git-based. These are commercial vendors that provide the service to you to make it a little easier, but they're not completely necessary to use Git. You can use Git just locally on your computer. You don't need to push anything ever to the cloud. But having that clarification sometimes help people understand, okay, Git is a standalone thing. And then there are some commercial vendors that have taken Git and put it into SaaS products and so on. It's a little bit like Linux in that sense, right? You've got Linux as an open source project, but there are Linux vendors, Red Hat, and so on, right, that provide support and capabilities around Linux that you might not get out of the box. Okay, so we'll talk a little bit of the under the hood aspects of Git. And so these are some concepts within, oh, that formatting went crazy. All right, sorry about that. But these are concepts within Git and terminology. So you just kind of, people will rattle this stuff off like me that have been working with it for a while. And so this helps you just know what they mean. So when you create a Git thing on your hard drive, you're going to create a repository. And most people will just call it a repo for short. And that's really just that vault where you're storing version controlled files. The working directory is a place within that repo where your files actually live, and you can make edits and so on. You can add new files, delete files, and so on. And so when you work with the Git command line tools, you'll see it'll say things like, this is untracked in your working directory. That's just where you're working right now. Version files are the files that Git knows about. So if you create an empty repo, and then you add a file in there, Git doesn't know anything at that point about that file other than it's untracked. So when you have that new file in there and you're like, hey, I made all these changes, but it's not like suddenly showing up automatically being tracked in version control. It's like, oh, well, that's because you never added it. You never put it into the repository. So that's an important concept. Easy one to make a mistake early on in your experience, but important to realize. Okay, a commit. A commit is another type of point in time in your repo's life cycle. So if you work on your files, so let's say you're creating a Python project, you work on the file and you make your changes and so on, and then you finally decide, okay, this is something that I'm good with, I need to save it for posterity, I got it into that place where the code's working, maybe it doesn't seem to have any bugs, I want to set that one aside, put it on the shelf, right? Put it in a lockbox. You want to commit those files at that point. That way you can then be safe that you can always get back to a working version of your application. So you look at commits over the life cycle of your project in order to go back in time, or just say, hey, like if I'm working in a collaborative project, did someone else make a change because things aren't working the way I expected it? You can go and look at the commit history and then understand, oh, I got to go talk to Frank because he seems to have introduced something into my application or our application that isn't working. So when you get to more of the distributed and orchestrated type of model, this commit history is very important, and the identity of the user who's in there is very important. And then branches. So branches is a very important part of, especially when you work in a collaborative world with other people on a project. You want to create a branch typically for you to start working in. You don't want to go straight and work in master. And the reason for that is there are certain workflows that are more convention than built into Git, but convention where if you create your changes in a branch, you can then submit those changes, people can review them and review them against the original versions and decide whether they want to accept those branches. So that's another thing to have fun learning about as well. Okay, so this is a bit of an initial life cycle of Git and some of the commands that you will need to do. Just checking my time. So if you have like a fresh laptop, you've never used Git, and you try to make a commit, it's going to complain to you. And it's going to complain that it doesn't know who you are. Sorry, I got to clear my throat real quick. And if it does that, you know, oh, I need to do this one-time setup of identifying myself. And I'm going to identify myself just by my name and my email. So you can see git config -- global user.name and then your name. Same with email. There is also an ability to store local. And that would mean you could have multiple identities per repo. So that's pretty handy. Like maybe you work on an open source project and then you work on a commercial, you know, your work day job thing. You could have your personal email identity associated with the open source project and then the work one associated with your work one. The next thing that you'll need to do typically is if you're not starting from scratch, you will want to clone a repository. And when you clone a repository, typically it's done from the internet, but it might be done from a file server. You don't have to have like a web server running in order to do this stuff. You can actually clone from another file location on your computer. So that gets a little bit cool, like to understand later. But this git clone mechanism will reach out to the internet, say on GitHub. It will pull back the project, and then you'll have it in your local directory for you to start working on. And we'll look at how that works when I do the demo. Status. So, okay, you've pulled the things down, and you want to just say, okay, like what's the status of this working directory? What's the status of this project? You type git status, and that will just list out the current status. So if you were, for example, to clone into an existing directory just by some mistake, and there were different files in there that were not from the project, you might see a state where the git status will say, okay, here's all the files that we know about, and then here's the files that these ones are in here, but we don't know about them. Usually you would use that later, probably in the process when you're working and adding files. You would say git status, and then you can know, hey, I got to add files or I got to delete files or what have you. Okay, the next step is to create a branch. And so when you create a branch, as I mentioned before, that's the intent of that is really to be able to put it sort of in a future state. So you're not messing with the master branch. And a lot of cases, people, you won't have rights to commit to the master branch in like the originating repo. So you pretty much have to go into a branch when you start. Otherwise, you're going to sort of run into problems when you try to push that code back up to the cloud location. You create a file next, and when you create that file, you need to add it to the repo. And so you just type git add and then tell it the file name or a wildcard, and then you can add those and it knows it's starting to track. Sometimes you might just walk away at that point and you're like, yeah, I'm good. Like, woohoo, you know, like, and then you're like, hey, did you get my pull request? And then someone says, I don't know, I don't see anything. What are you talking about? And at that point, you're like, oh, I forgot to commit. Oh, shoot. So then you got to go back to your computer. You got to commit your files. And you have to put in a message. So you would say, hey, like this is a change, maybe a bug fix or what have you. And you want to do reasonable commit messages. If you're in a real project, you have to do a good commit message. And there's blog posts about how to write good commit messages. But the important thing there is really to convey, like, what did you really change? Are there any, known side effects, those sorts of things, so that someone, when they look through the commit history, they actually can, can use your comments. It's like writing a letter to your future self. It's like writing a letter to your other people in your company. There. Okay. And then the last thing is if you make a mistake and like, oh shoot, like I've gone way off the rails. This stuff I've added to the file it's never going to work. You can just reset that file by saying git checkout file name, and it'll delete all your old work and bring you back to where you started. So that's kind of a life cycle, I would say, of git commands and how you can work with your files. And so this is a little bit of the same thing. But so I'm going to go through this real quick. But basically, you clone, you check out, create a new branch, you add your file name, and you make a commit message. So this gives you a sense visually of the code started on the original repository here on GitHub. You want to get it to your computer, so you clone it, right? After you clone it, you get the code on your computer, and you're able to make some changes to the file names like here or here. And so once you've made those changes, you commit them, and eventually, maybe on the next page, you push them back to the server. So that's the theory. Let's see some of this in action, and we'll see how rusty I am. But I think I'm okay. Cool. Okay, so let me share the right thing. How do I share the right screen? I'm not sharing this anymore. Do I just drag it over? Or do I have to mirror? Sorry, technical difficulty. This will be difficult to do this way. Okay, 1 second. It seems like it's mirroring, but it's not. Yes. Just slide it over. Okay, well here's what we're going to do then. Okay, this is going to be interesting. How long is this? Do you mind if you scoot over one chair? Because I obviously I won't be able to see anything. Okay, so this is one thing a presenter should never do, right? Put their back to the audience. But let's try this. This is kind of fun. Cool. Okay, so that's a GitHub repository. So this is my personal one, and I'm trying to get my terminal over there. Give me a second. Oh boy, it's not going. Where is it? Holy moly! Wow, this is interesting. It thinks it's mirroring, but it's not. I'm going to unplug, and then I'm going to replug. Okay, so I lost my browser now. Okay. That is not, okay, hold on. Nope. Window. Okay. I sort of figured it out. Oh, it went behind. Maybe that's what's going on? Dude, this is weird. Okay. All right, so I'm just going to try and do this from memory then. Okay. Let me make this really big. Okay, so I'm going to make a directory here real quick for us to just have fun in Scratch. Can everyone see in the back? Good enough? I can make it bigger. It's no worries. Okay, so in here, we have an empty directory. And so what we have to, one thing that Git is really good about actually is like the command line itself is fairly, it can help guide you pretty well. So if you're like, I don't know where to start, you can just hit Git. And so these sets of commands are really the basic ones you need to know. So it's like, okay, am I going to clone a repo to a new directory, or am I going to initialize a blank directory? So what I'm going to try to do is, if I can navigate to that other web page real quick. Cool. I'm going to, I did a presentation the other day, yesterday, on this human-centered design and discovery resources. So I'm going to clone this repo. And when you clone, you have multiple options depending on how you set up your computer. If you set it up with an SSH key, which I would totally recommend, because otherwise you're going to be having to enter your password every time you try to push or pull or do anything. So if you don't know how to generate an SSH key, learn that. That's an important thing to learn how to do. But I already have it set up. And so I'm going to say git clone. Oh, that's at the bottom. 1 second. Git clone, and we paste in that directory. So this is going out to GitHub. It's cloning the folder. And what you'll notice is you're not inside the directory. So sometimes that can trip people up, where you just start working and you create all your files outside of the actual repository. So make sure you cd into the directory before you do that. So this is not a complicated repository, as you can tell. It just has one README file. And so I'm just going to go up here. And what we'll do is we'll add a new file. So we'll just do readme like part2.md. So you can see, like, I'm not doing any coding here, right? I'm just working on Markdown files. So the reason I mention that is you can use GitHub on Git for a lot more than just coding. So if you're writing a book, I use this note-taking tool called Obsidian. It's all Markdown based. So you can use like Git as a way to version control all of your notes. So just, it's a very flexible tool. So now we have README, and I meant to put part 1, but README-PT. And so if I say git status now, you remember that command, you can see it says untracked files, and the readme-pt.md is untracked. So if I'm going to make a change to that readme.pt, I can come in and make a change, like hello from Amsterdam. Did I spell that right? I think I did. So now I can do the same thing, get status. And it's the same, right? But what I can do is say get add, and you'll notice like get tells you, says use get add file to include what will be submitted. So you don't have to memorize all this stuff like right now. The command line tool is going to help you quite a bit. And there are GUI tools too, but it's good to do the command line sometimes initially. So we'll do readme pt, and now let's look at that status again. So get status. So cool. So it went from red to green. That always is a good thing. And so changes to be committed. You have the new file, and it's readme-pt. So from this point, I'm still in the branch called main. So I violated one of my rules that I said you should never work in main before. Oh, one little historical thing. It used to be called master, but they've changed it to main. So sometimes you'll see master, and that's due to the sensitivity, obviously, of things. But so you may see repositories that have master, some say main. So that could be something that trips you up. Don't get too worried about that. But the default is main now. So I'll just say get add, or I already did get add. So if we want, we can just commit this and then push it back up to the repo. So I'll go ahead and do it. So we'll do git commit. Don't forget your message. Example file add in AMS. Cool. So you'll notice these like, okay, this is weird. Hold on, sorry. Yeah, so these hexadecimal or values, these are the commit hashes. So when I actually commit it, that's the thing that shows when you do commit logs. It's how it tracks all the changes internally. It is also, I believe, cryptographically secure. So that way you can know if a file was tampered, or Git will check if a file was tampered on the file system. It will alert you to it through these SHA hashes not matching. So it's very secure from that standpoint as well. The other thing I'll point out here is this. So create mode, it does bring across like high-level Unix permissions. So if you do end up in a situation where a file might need to be executable or something like that, you can change the permissions. That will persist across clones and pushes and so on. So that's also good. Cool. So the last thing to do then is, and before we do that real quick, I want to show you one thing. So here we have just README, and I'm going to make it big again and close this. So this is the only file in the repository called Human-Centered Design Product. So I'm going to refresh the page. So you see that's the only file. The last one was 3 days ago, and so on. So now, if I do git push origin main. So origin is an alias for that repository. That's just the default that gets used. When you clone a repository, you can give things other names. I won't go into that yet. But you git push, and now it goes and it talks over the internet and pushes that stuff up. So it told you a bunch of things. It went from C0408F9 to DB6D12F, right? So this DB6D12F, and then I'm going to pop over to that browser. You can see this is C0408F9, right? So it knows that's the commit point that was here. And we have the new one that was created locally, and now when I refresh this page, you'll see it changed to that new value, and you'll see the file is up there. So now this is available for anyone else in your organization. This is available publicly. You could go and mess with it, but you couldn't push anything because you don't have rights to the repository. So there you go. that is the tour of Git. Git in 15 plus 15 minutes, 15 minutes squared, I guess, maybe. Nah, multiplied by 2. And so, yeah, thank you so much. I hope this helped you out in kind of demystifying Git. There's a lot of stuff to have to deal with, but you can get there. I never knew this. I don't know, it was like 8 years ago, so proof that you can learn it. Okay, so we're doing the raffle now. And this is for a Fire TV from Amazon. Amazon did not sponsor this, just happened to be the thing. And we have number 319. 300. Oh, wow. Cool. All right. Well, come on up. Thank you so much. Enjoy the rest of the event. And if you have any questions, please, I'll be here. Happy to answer them.